Hi, I'm Trevor Haney, and this is my Capstone Project. So to begin this Capstone Project, I wanted to first figure out what kind of scientific inquiry was I going to be aiming for. I decided because it was the end of this school year, I wanted to try to have an open inquiry type of assignment where the students would investigate topic-related questions that are student-formulated. I decided I would be able to achieve this goal by an open-ended design. I also wanted to make sure that this was going to really incorporate all aspects of STEM. So the problem that I gave the students was to create an automated guided vehicle. The prompt I gave the students was an amusement park would like for your team to design an automated guided vehicle, AGV, to drive around their new ride, Safari Park. I chose this topic because we had just finished up our robotics unit, and it was a perfect way that I could tie some robotics into this capstone project. So the criteria and constraints that I gave the students, the passengers for this Safari Park ride would be the sensor tags. The aim of this was to create a very smooth ride while getting around the loop, which was the ride, as fast as possible. The students were able to use any of my Vex Robotics tools to create the vehicle, and everything had to be recorded in their notebooks, and they were able to use the computers and Robot-C to create their code. And unfortunately, due to time constraints, we only had 3 class periods to get this all done. So students jumped right into it because they knew that we didn't have much time, and they had to define the problem, conduct research, and come up with technical drawings. The picture on the left are some of their defining the problem and coming up with a little bit of research. They had to do all of their own research. They found online some previously done line following kind of robots that they decided to kind of go with. There were some technical drawings. I kind of wish that they would have had some more details in those drawings before they started to build, but just because of time constraints, I kind of let them move as quick as they possibly could through this project. Then they were able to start to build. So here's Esteban, one of my students, and his robot to the left of himself, and he is trying to program it. The actual code that he decided to use is right there on the left-hand side of the screen. Every single thing for the code was all based on them. They had to do their own research to figure out what the line-following sensors would be able to read. Then they were able to test it. I had a nice little loop around my classroom, which was considered the ride. Here's an example of a pair of my students trying to figure out how the robot could work. And then here's another, the most successful robot that I had. And the sensor tags are located on the robots. It's located right underneath the computer there. So the sensor tags were a little inconclusive. There was a lot of rocking. I kind of let the kids try to figure it out. It was kind of inconclusive per se. I kind of would like to do this activity next year, have a little bit more time, and be able to play around with the sensor tags a little bit more. There was clearly one design, which was that last video there, that was the best design for this activity. And my takeaway is this project was very, very fun. The students really liked it. The students were engaged the whole time. That could also have been due to the lack of time, because today was the last day of school. And the students were able to do a lot of coding. They were able to find out how to use the sensors that were included in the Robot-C equipment. They were able to create their own designs, which was pretty cool, and they learned teamwork. Thanks so much for watching.